Okay, so there are a few things that are going ahead and that are happening here. So first and foremost, we have exothermic and endothermic. So in exo, you got to think of the fact that it's going to go ahead and it explodes and that it gets warmer. So those are the things that you guys have to think on there, is that it gets warmer. So I have something on here, and then this is my system. That's where my reaction is taking place. All around it, that's my surroundings. And in exothermic, what's going to happen is that heat goes from the system to the surroundings. So that's what you have on there. Endothermic is the opposite. Endothermic is going to get colder. So in endothermic, what's going to happen is that the heat is going to go from the surroundings to the system, right? So this is going to be, that is going to be where your heat goes, right? Our next set of things is going to be product and reactant. So going ahead and kind of backtracking into bio, we have our products, which is what we start with, right? So we have CO2 for a plant to grow. We have sunlight, and then we have water, right? And then that makes glucose plus oxygen, right? So this side, what we put in, this is going to be our reactant. And then if we go to this side, this is going to be our product. So that is kind of like the difference between those two things. Okay. The next thing is going to be solute and solvent, right? So you have to think about this deal. So if I have like a cup and it has some like water or something in it, right? The water that I start with, this is going to be my solvent, right? What I put in it, so say if I'm going to go ahead and I'm going to add some salt to this, right? What I put in it, this is going to be my solute, right? And together, right, when I go ahead and when I add my solute plus solvent, so my solute plus solvent is going to be my solution. So that is what you guys have on there. Ionic bonds and covalent bonds. So there's a couple of things that you guys have to know. Ionic bonds, this is when we go ahead and we steal electrons. So that is when metals give electrons to nonmetals. And the way that you guys can tell is that when you guys are looking at your periodic table, we have a line that separates some of our metals from our nonmetals, and we'll get into that a little bit further on, right? Covalent bonds is when we share electrons. And that's going to be between two nonmetals. So that's what's going to happen on there, right? So that is our thing on there. A chemical reaction is something like we have up here, our reactants plus our products. That stuff together is going to be our chemical reaction. So we start with one thing and we end with another thing. Okay, and then valence electrons are outside electrons. So our electrons that we have on the outside, so on the last ring, we can go ahead and we can look at that, and that will be our valence electrons. Okay. Endothermic, exothermic, I already shared what kind of happens with that. So if we look out here, right, we have to think about where the heat is going. So in endo, right, we have our heat that is happening, right, and we go ahead and we bring heat in, right, so this is going to be our heat. So the heat goes from the surroundings to system. And then for the other one, right, it's going to be the opposite, right? So I'm going to go from my system to my surroundings. So this is exothermic, right? You guys have to also think about temperature. So in this thing, temp is going to go down. Okay, so as I was saying, right, in exothermic, the other thing that happens is that the temperature is going to increase. So we start off with like some temperature, it doesn't matter what we start with, right? We record it and then the temperature goes up. So very similar to some of the labs that we have been doing. You guys see that in endothermic, the temperature is going to go down, in exothermic, the temperature is going to go up. Okay, so how are molecules connected in an ionic bond? So in an ionic bond, the big thing to remember is that molecules are attracted to each other due to charges, right? So in this case, they're connected due to opposite charges. You have to remember that, for example, we end up with an Na plus and a Cl minus, and those things are going to snap together like a magnet, and then that is going to be your ionic bond. Okay, your types of atoms that are involved is going to be a metal and a non-metal. And again, you guys can go ahead and you guys can tell this. You guys can go ahead and you guys can tell using your periodic table. And I'm going to bring that up with you guys right now. The other thing that you guys can do is that you guys can look at this, my periodic table. Oh, shoot. I think I didn't. Table. So if you guys go ahead and if you guys bring up a periodic table, it doesn't matter which one it is, right? This one doesn't have a good line for it. So when you guys go ahead and you guys look up a periodic table, very commonly what you guys will see is that you guys see a bold line between your metals and your non-metals, and it goes ahead and it separates what is going on here. So, for example, if I were to, I don't see one that I really like, but let's go ahead and let's go with this one. So on this periodic table, what happens is you guys will go ahead and you guys see that on your periodic table in like this area right here, what you guys will see is a bold line. So you see this, all these green guys, there's like a bold line that goes in between. So if you are in like 14 through 17, those are all non-metals. But if you go from like 13 all the way back to group 1, those are all metals. So this side is metals, right? So on this side, so 1 through 13, you'll mostly get metals. And then on this side, what you guys will get is your non-metals, right? So that's kind of like your important thing that you guys have on there, right? So in a covalent bond, right, what happens is that we share electrons. And then what we're going to have here is your types of atoms. In this case, it's going to be your nonmetals. So the ones that are on your right-hand side of your periodic table, that's going to be your nonmetals. Okay? So how do you find the number of valence electrons of an atom? So again, right, you guys are going ahead and you guys are looking at your periodic table. And if you look at this periodic table, what you see is like a 1A, a 2A, 3A, 4A, 5A, 6A, 7A, 8A, right? So if you guys look at those are hints on how many valence electrons there are or how many electrons are on the outside. So what you guys are going to do is that you guys go ahead and you guys look at that and you guys are able to look at those numbers. Right, and then that is what we kind of go ahead and that we see on there. So in this case, in a covalent bond, we are going ahead and drawing lines between atoms. Right, and we're going ahead and we're representing sharing. Right, and that's a big thing, is that you guys need to be able to represent the sharing. Well, in this case, an ionic bond, we're going to be going ahead and we're going to be doing arrows, right? And that shows that electrons are given. And the super important thing is that you got, okay, so getting back into this, right, we have ionic bonds, and don't forget the charges on the atoms, because that is going to be the biggest deal. So we're going to look at this one, and we're first going to go through this, and we're going to see if we can go covalent or ionic, and then we'll go ahead and we'll go through this one. So the first one's a little tricky. We have hydrogen, and we have aluminum. So we have hydrogen here and aluminum right down here. So we have to determine which things are metals and non-metals. So don't forget that everything on this side, this is non-metal. So, and I'm looking at this like squiggly black line here, and that's what I'm determining metal and non-metal, right? This side is going to be metal. Hydrogen is actually a non-metal, but it does have kind of properties of a metal, so that's why it kind of makes it tricky. Okay. So in this case, right, aluminum is a metalloid, so it's kind of in the middle as well. So what you guys will see on here is that aluminum and hydrogen are actually going to go ahead and they're going to help each other out, and they're going to bond a little bit uniquely in the sense that they're going to go ahead and they're going to bond covalently. Aluminum has 3 valence electrons. Again, I get that from going ahead and looking here, and I see that aluminum is in the 3A column. And then I know that hydrogen has 1 electron each. So I go ahead and I do that. So that would be kind of the thing on there. So that one's kind of a trickier one. So that one is a kind of a little one that's a little off, but just so that you guys can see that some of them do require A, and this one is going to be just one that happened that it doesn't. Okay, the next example is carbon dioxide, so CO2. It is covalent because if I go ahead and if I look on here, carbon and oxygen are both on the nonmetal side, so I know that this one is going to be covalent. And for CO2, I go ahead and I start with my carbon that has 4 valence electrons, and again, I get my 4 valence electrons from this 4A right there. My oxygen has 6 valence electrons. So I'm going to go ahead and I'm going to draw my carbons, and I'm going to draw my 2 oxygens. Whoopsies, I don't want to do that. And what I do on covalent bonds is that I go ahead and I get those things all good to go. I connect them, and that is it, right? So I have my carbon dioxide. This one is O2. We already know that oxygen is a non-metal, so that one is going to be covalent as well, right? And I'm going to draw it on this side. So I have oxygen, 1, 2, 3, 4, this, and I draw another one, and I connect those deals, and then once I connect them, I see that I have 2 of them. I count up my electrons, so I go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. Right, so those are going to be some of my things on there. My last one, my next 2 are actually both going to be ionic. Right, so I have my Ca, which is right here, and my Br, which is here. So that is again a non-metal. Oh, yeah, metal and a non-metal. And then on here, I have Al, which is aluminum, and fluorine. And then that one kind of functions as a metal because it's on this side of this line right here. And then this fluorine is a non-metal. So both of these deals are going to be ionic. And they go ahead and they bond a little bit differently. Okay, so we're going to start with CaBr. So Ca. Calcium has 2 valence electrons, and again, if I look on my periodic table, I see that it's under the 2A. And then I have my bromines, and they were nice enough to tell me that there's 2 bromines. And bromine has 7 valence electrons because it's in that 7A group. I go ahead and I donate those 2 electrons from calcium into bromine. And then I'm going to get a Ca2 plus, because you have to remember that the 2 plus is how many electrons that I donated. And then I get my Br minus. So I go ahead and draw my full Br, and I have 2 bromines. So I go ahead and I write that. So remember that this one is going to be your number of atoms And then this one is electrons. So you have to remember that those are going to be, right, so you guys have to remember that this side is going to be your electrons given, right? This all refers to electrons, and the number in front is your charges. So AlF3, same thing. Aluminum has 3 valence electrons, right? Fluorine, again, has 7. So I go ahead and I draw my fluorines here. So I'm going to go ahead and I'm going to donate all of these electrons on there. And what I end up with is an Al that's given 3 electrons away, so it's going to be 3 plus, right? And then I have my fluorines that are now my happy 8 electron fluorines. They each of them have a negative charge, but there are 3 of them. So I'm going to go 3 fluorines that are negative. So that is what you guys go ahead and write on there. So remember this right here, number of atoms, this right here are going to be your electrons. Okay, so what can help increase reaction rates? So like I've been saying, like if we're talking about Kool-Aid and we're talking about making a mixture of Kool-Aid, there's a couple of things to keep in mind. First and foremost, right, if you guys can go ahead and do that, right, stirring it really helps. And the reason why stirring helps is that when you guys stir something, you're going ahead and you're exposing more of those molecules to go ahead and to hit each other and to cause a reaction. The next thing is heat, right? Heat, again, right, you're moving molecules. So the thing that really helps is moving molecules, right? The more you move the molecules, the more they're forced to interact. To interact. So that's going to be like the big deal, is that you guys need to make sure that you're kind of putting those ideas together, is that stirring them and adding heat, right, will make molecules interact, which will then make reactions happen faster. Okay, you guys, so good luck on your test, and if you guys have any questions, please do not be worried about emailing me or going on Remind. And my class code for Remind is at PonteChem. Okay, thank you guys, and good luck.